Good afternoon. Thanks for joining us on May 2nd here with Mark Long, who is the Civil Hydro Training and Support here at Carlson. This webinar is for Civil Suite, Storm, Drainage, and Design. My name is Lee Garang. I am the Marketing Assistant here in the Boston office. If you have questions during the webinar, please type them into your webinar toolbar, and we can get to those at the end. And as always, the webinar recording can be found shortly after this webinar has ended at our YouTube channel, which is youtube.com/Carlson Software. So we don't have much time, so let me hand it over to Mark and he can get it rolling.
Thank you, Lee. Let me see here. Let me get my stuff. Can you guys see everything okay? Can you see that, Lee?
Yep, looks good.
Thank you. Okay, so we have quite a bit to talk about today and go over really quick. The first thing I want to do is start off with watershed layers and how we use closed polylines and layers to designate our runoff coefficients or curve numbers. If we go up to watershed inside of Carlson Hydrology and we come down to define watershed layers, you can see that I have 3 already in here. What I have included here is a W buildings, which is roofs inclined with a runoff coefficient of 1, roadways 0.82, and driveways, which are concrete, are 0.88. If we were to hatch all, we can see that these hatched areas are those different areas of ground cover that we assigned. Now, how do we go about signing a new one? If we go to watersheds and define watershed layers, we could add a new one. I want to select a layer, so I can select, and I'm just going to screen pick my tree line. Okay, trees, what's the ground cover? We go into our library. We see here that this, I believe this comes out of the TR55 manual. It's one of those technical manuals. But we can come down through here and find, we could just say unimproved, or we could say this is woods deep ground litter. We'll go with this guy. Say okay. Now, we can hatch this and select a hatch pattern for this. If we go down to maybe, I don't know, we could probably find something in here. What if we set this and select OK? You can see it gets added to our list, and we can say hatch all. And you can see that it gets hatched. The reason that we use closed layers and layers and closed polylines is because if it doesn't hatch, it's not closed. So it's kind of a graphical representation for you to see. And this is usually about this. This is the very beginning things that you want to do in your CAD design that you've already got this information, so you can create these watershed layers for your storm drainage runoff. Same thing works in the if we go into the SCS method and the HydroCAD method. Just so you know, the SCS method, those numbers range, the curve numbers range from 1 to 100. Rational method is 0 to 1, and the HydroCAD gets assigned based on layers in HydroCAD. Okay. So I will leave that, and then you can also see that the default ground cover, we're using lawns, heavy soils, comes right out of this same thing, steep soils, we'll just call it that, maybe that one. And it gets a default runoff coefficient of here. If we are using soils, we want our soils line work to be on a layer closed, okay? And we want a piece of text that represents the letters A, B, C, and D type soils to be on their own layer as simple plain text. It can't be multi-line text, just so you know. Your watershed line work layer, we assign that. I typically use W, and I'll show you why. If I come into my list and I hit W, I can get down here to these W's and turn them off and on really quick. That's one reason why I use W. Our watershed labels, will be put on a watershed area dash text, and then our runoff flow polyline we can place on a layer as well. But that's really a very brief and quick way of getting your composite or weighted C inside of Carlson software by just doing simple CAD setup, you know. So I'll say okay. Now, since I am quite limited on a little bit of time, I do want you guys to see that the storm drainage design itself. So I'm going to kind of just move on into that. So in order to do that, the first thing that I want to do is come into my network, sewer network settings. Okay. Here I can specify whether I'm doing a storm network or a sanitary sewer network. Okay. I am going to do one that is called today's date webinar.sew, and I do want to select a surface file or model, which is, you know, maybe from RoadNet, that we are going to use to assign our rim elevations on our boxes. Okay. Anytime you see inside of Carlson software where it says link sewer network to reference surfaces and center lines, or you need to have this prompt off or auto. I prefer prompt because I don't like things changing without me knowing it. But if you like that, automatic type of updates happening, you can certainly select auto. I'm just one. If you get prompt, it just gets prompted and you say yes or no or whatever you want to do. I am using just my current inlet library, structure library, some pipe size libraries that I've already created. And I do have movies on those libraries on the Carlson website. Or if you would like, you can always email me and get them. As we work our way from left to right, we're going to go to the Design tab. We are going to start designing upstream to downstream in this case. Okay. We want to make sure that our auto connect structures, again, here's that prompt, off or on. The HGL computation method, we have the Federal Highway. We also have Virginia DOT and something for Ohio. Our friction slope averaging method, we have that. We have arithmetic, conveyance, and geometric. HGL offset from the rim. You know, I usually keep mine 1 foot from the rim of the structure. Time of concentration, usually here where I am located in North Carolina, my minimum time of concentration is 5 minutes, usually for my pipe design. Max gutter spread is about half the travel lane here, but I've got it set at about 8 feet. And my network structure start name. So this is going to be the very first structure that I put in will have the name CI1, which for me represents curb inlet 1. Okay. Now, if we go to the drainage tab, we have options for hydraulic methods of rational and the SCS method. We can solve for peak discharge and hydrographs. If you want to adjust the rational method for higher frequency storms, we have that built into the program. I think it's like a multiplier. Use different rainfall events for inlets and gutter spreads, ponding depth calculations, which I do use here because I will design my pipes to the 10-year storm, but I want my gutter spread and bypass calculated based on a different storm event, and I'll show you those really quick. My rational rainfall library, if I go and I'm using a rainfall intensity lookup table, we can edit it and see the different storm. 5 minutes for 10-year storm is 7.08 inches per hour. So we can just say okay, and just so you guys can see that, no, I'm not going to change. I do use a rainfall, an inlet rainfall based on Wake County, North Carolina gutter spread, which is a fixed intensity that if we edit that is just 4 inches per hour. Okay. Also, if you do use the SCS method, you will get some options down here that you can set specific things to. Always capture all inlet flow. This assumes that all the rainwater that falls from the sky goes into your inlet. It's kind of a safety feature, if you ask me. That's how I kind of looked at it. We know that we're going to have bypass, and bypass is still being calculated. It's just when we size our pipes, it's assuming that 100% of the rain goes in the inlet. We can go over to our pipe tab, and here in this settings area, we can specify what is our minimum cover. Let's just say we want 3 feet of cover and 10 feet max. So basically what this does is this lets the program let us know if we don't meet or exceed a value. Okay, and so we can specify these kind of flop, like my minimum slope. Well, I can do 0.5%, here, but I always be a little conservative just so I can adjust things later on. My maximum length between structures is probably going to be about 400 feet, just so you guys know. The normal slope that I want to design is 0.75%. Drop across junctions, yeah, I want to do 2/10 across my junctions. Now, I know some folks who don't. I know some folks that will use 1/10. It's up to you. But if you set drop across junction and you set for all junctions, then then everywhere there's a structure, you will get 2/10 drop. What is your pipe at junction match? What's the main design criteria? Do you want to match crowns or inverts? Well, for storm drainage, I'll tell you, matching crowns will drastically help your HGLs. So that's the way I roll. Main design criteria being cover or slope. Which one's the most important to you? I do cover. Then check my minimum cover. I like to do it at structures because if the structure's deep enough to handle a pipe, then I should be pretty good. You'll be able to visualize and see it shortly, but that's how I do it. Size pipe at target flow depths. You can opt for that if you like. The lateral portion of the network is more related to a sanitary sewer, clean outs, that type of thing where you can design clean outs for in this case that what we're looking at here, a subdivision for your sanitary sewer. In the air check options, we have the ability to check collisions with another sewer network during design. Okay, so if I had a sanitary sewer that I've already designed, I could check this box and then design my storm drainage with a conflict tolerance of 18 inches so that the program would notify me if I was within crossing pipes. Also, the manhole integrity, you can also check that here as well. Our display, we have options in here to do pipe length or actual pipe length, center to center or actual. Our pipe slope from center to center or actual pipe slope, percent or feet per feet, and the elevation decimals if you want those. And also this, if you guys look, I'm also testing with 2017. So you guys will know that this is maybe some new stuff. If you don't see it on your dialog boxes, it's because this is coming to you. So anyway, that's once we have that set, okay, and we've gone through each of these tabs and kind of set our criteria the way we want it, then we can click OK, and then it just kind of becomes down to create a sewer structure. Okay, now with my folks who are new, I always say go and do each structure one at a time. There are ways to speed this process up, but while you're learning, just do it just like I'm kind of showing you here. So create a sewer structure, and I'll come down here, and if you look down here at my command prompt, what it's doing is saying, do you want to pick, number, or center line? Well, I'm going to hit enter because I want to pick, and basically what happens is I'm able to pick inside of my drawing, and I'm also getting the I don't know, this kind of notification thing, that thing we could turn off, that's telling me the northing, easting, and the elevation of the surface model where I'm picking. So if I pick at the endpoint, I've basically kind of just roughed in, in this case, where my inlets are going to be. And so I'm just going to pick. And the program, remember, CI1, We come down through here and we specify as much as we possibly can about structure 1. Okay, well, he's going to be a combo. He's on grade. I want to be a curb inlet 5x5. These are coming from my libraries. The structure 1 name is set. I could come down here. I could set my reference center line, and I could screen pick a poly. And you guys see my center line right there. It should switch to RO1. That's good. My symbol name, I need to set my symbol name to start with. And I'm going to show you, if you look down here, I set some up for some folks in Arkansas, and I added them into my library. But these are North Carolina NCDOT. So I'm just going to use this guy. And I will go with the direction my box is oriented to parallel to center line down, I think. Yeah, see, it rotates my box based on that. And then since I draw everything that 1-to-1 in my drawings, that unit symbol. So what we're looking at here is an actual 5x5 catch basin, and you see the inlet, the grate, and the open throat. And now we've basically set, some basic parameters here that will be used as we keep adding structures. Now, the first thing I would tell you to do is you can look down here and you can see there's my rim elevation. Okay, I've got 4 feet of depth on this structure. Well, if I add a 15-inch pipe in, you already know that I'm not going to have the cover that I want. So let's go ahead and just set this first box right. So usually with a 15-inch pipe, I could go, I don't know, maybe just say 1.5 just to be on the safe side. When I click enter, the program automatically calculates the invert out. I am 5.5 feet deep. Okay, if I want to round this, I certainly could, just to make life easy for my surveying friends, and there we go. Now it just basically, we've set everything that we can about the first structure. Okay, next thing we want to do is we want to go to the next tab, to the drainage tab. Here's where our watershed layers that I talked to you about in the beginning and the drainage areas and things like that come into play. Now what I'm going to do here is I'm going to show you how the program calculates drainage areas based on your surface model. You see this blue line out here. Okay, this blue line is mine, but I'm going to let the computer calc this based off of the surface model I created with RoadNet. So if I hit calc, it takes it a second because it's going to load this surface in. It's going to do all kinds of behind-the-scenes calculations of sinks and all kinds of stuff. But you'll see when it pops back up here, the drainage area that represents what's coming to CI1. So we'll just let it ride and let it do its thing. It's checking so much stuff. And when you do the first one, it takes this long because you have to load in the surface model. But then if you just keep on adding in from the dialog box, it speeds up pretty good after it's all said and done. But we'll let it, there it is. So there is the drainage area that it gave me, which is this green line, okay, based on my surface model. All right, well, let's look at it over here. It's in acres. It's almost 2/10 of an acre. My time to inlet got automatically set because I hit the calculate button. I'd probably go back over here and change that to 5 minutes. And then my, hold on. My runoff coefficient didn't get adjusted. Let's see what's happening. If I define watershed layers, that should be good. Say okay. Let me try and pick and see what I get. Let me try and pick my blues. This is just my blue one here. Let's see what happens. Okay. That's something for me to note to myself. Runoff coefficient. You see how the runoff coefficient changed to 0.44? Well, here's what I was expecting to see. So by us setting up the watershed layers, at the very beginning of the webinar, you can now see that I've got, here's my long sandy soils, here's my streets, here's my driveways, and here's wooded, this wooded area that I added up here. And you can see that, say, okay, well, that weighted C or composite C is 0.44. Okay. Now, if we had a known flow that we wanted to introduce into this inlet, then we could select and put in a known flow. If we put it here and just type in, 25 CFS, it will be coming in through the pipe. If we say check this box, add it through the inlet, it gets counted into the bypass too. So also, when you do your very first structure, I would highly recommend that you go ahead and calculate the longitudinal slope and the pavement cross slope for your gutter spread. We don't have any other inlets in here, so we can't really set our bypass yet. But this is what you would do. We don't have a pipe. We don't really have any hydraulics yet, but what we can do is come over here. Now it kind of becomes a rinse and repeat type of process. We can come up here, this plus sign for add, and pick a point, just like we did earlier, and come right over here and snap to the endpoint of my dummy line. It tells me, it gives me it's going to auto connect. This is where I'm being prompted for 27.26 feet. I'm going to say yes, this is a good check. Now, why is it 0.26 feet? This is a 27-foot back-to-back. I'm going to show you why. If I say yes, and it adds in this structure for me, it's checking sinks and all kinds of stuff, but that's all right. So it adds in structure 2 for me, and if you look, I've got a widening taper right here, and that's what's the additional footage. So if I come back over to the structure tab, and I want to make sure that I rotate my box, because you see my grates in the utility strip, I want to rotate it back around to parallel to center line up. That box gets rotated. He adopts all of the previous structures, pretty much all of its stuff. You may have to rotate your symbol just to get it to your center line. You may end up having to adjust your center line if you move things to another place. But for the most part, we have basically added a new structure. It's adopted, and its its depth is 5 point. So it's calculating this sewer. If we look at it, we can see that there it is under the road, just under our hydraulics tab. If we go to the pipe, you can see that now we need to specify the information about this pipe, because it's our first one. So because everything else after this will adopt this same pipe. I want to do RCP3. It's circular is fine. Well, here in North Carolina, I can't use a 12-inch on my storm drainage in public streets, so it has to be a 15. So I need to change it over to a 15-inch. You can see the inverts here. The slope, remember that 0.55 where I told it to try and do minimum? That's what she's doing, because there it is, 0.55% on that pipe. If I wanted to add step-ups, I could do that here and all kinds of good stuff. But what I really want to do is kind of slip over here and let's select the drainage. The last time I hit calc, this time I'm going to select, and I'm going to pick a perimeter polyline. Pick my polyline, and it'll give me, it's almost an acre, 0.32. Well, let's see what we got this time. Well, this time we've got some driveways, we've got streets, we've got roofs, we've got woods, we've got grass, we got all kinds of stuff. But we get a weighted runoff coefficient. Okay, and you can look at this and kind of tell that the grass in the woods, I mean, it's good. Now, the pavement cross slope has already, the longitudinal slope is automatically gets calculated for you from now on out after we do the first one. And always a good check is your cross slope should be pretty close to crown, normal crown. So you can have that. And if we go over to the pipe tab, we've made our changes here. We could analyze the network at this point and look at it. We didn't get any errors, so we're good. But if I go into the hydraulic tab, now you can see the HGL and the EGL, okay, here and here. I'm going to show you other places for this as well. But for this and my time constraint, I'm going to just show you this. Now I'm going to do something else. I'm going to exit this. I don't want to save my changes. I'm going to come up here. I'm going to set my sewer network to storm drainage. I'm going to do one that is, let's see, pre-sizing maybe. Is that pre? Maybe that one. Let's go this guy. Open him. Okay. Now what I'm going to do is basically I showed you the process of creating a structure, add another one. It's kind of rinse and repeat on down through the system. What I want to do now is I want to show you, and I want to draw a plan view. So now what you can see here is I put all this in, and for the safety sake of time, everything is a 15-inch pipe. Okay. All the stuff that I assigned to this one and this one have already been assigned. Okay, I've given drainage areas, I've looked at everything, I've verified everything, and what we can do now is we could go and look at this in the spreadsheet sewer editor. Okay, so if we look at the spreadsheet sewer editor, here's what we're kind of looking at here. You can see the HGL and the EGL the pipes are under pressure. This one's surcharging. That one's getting out of control. If we go over and look at up to CI1, which was my very first structure, up here he is. It's all 15-inch pipe, and it's just kind of running down the street, got pipes under pressure, all kinds of good stuff like that. But just so you can also modify things here. If you look, and now new in 2017, this is like the blessing in disguise for me, because I constantly switch back and forth what I'm doing. And now I'm designing upstream to downstream. So if I was to come over here to, well, we'll go down here to the bottom, down upstream to downstream. If I was to change this slope here, it's going to hold my upstream invert and change my downstream invert if I put in a 1 and I say I want to go at 1%. And so now my pipe gets the invert. Well, actually the upstream got adjusted. No, it didn't. I think it's okay. Anyway, so there you see. Now let's go back to our sewer network, because I want to show you guys something that's really cool. Save change. I'm not going to save these changes. I want to come back in here. I'm going to come into my network, and I will just double click on sewer network. It opens up this dialog box, and here's the same kind of stuff you guys were seeing before. Maybe I ought to change this to be 5.5 feet. Okay. We'll just drop that pipe down, be 5.5 feet. Now, if I come up to this settings gear, if I come to this design tab, I can have the program do all kind of automation for me. So if I come in here and say, I want it to auto set my sewer pipe sizes and do this, and we can add a step to minimize excavation, and who knows, what would I put in here? I might put 2 feet. Auto match pipes at junctions. You can make your own opinion about that. Auto set the invert in when the invert out changes. Minimize your pipe sizes. Don't do watershed analysis, because it takes a long time to do this. But I might do that guy. Click OK. So we just told it, we've got all these 15-inch pipes. We've got all this HGL. We've got all this information. And let's let the program make the decisions and design this for us. Remember, every one of these pipes is 15-inch. So if I hit this design button, it says, hey, are you sure? Now, this is being prompted. So I say yes, and it'll go through and it'll say done. It's telling me I've got some velocity problems here and there, and I may have pipe cover. Oh, I'm over 12 feet deep. Okay, so I've got to, now if I double click on this, well, I think I thought it would. Might have to say zoom in or zoom to. Here it is. It tells me where I'm at, shows me. So I can exit this and come back and, let's see here, let's save and exit. And now if we come back into our spreadsheet sewer editor, you can see that now the pipes have been designed, in a nutshell. Now, why it's giving me an 8-inch and when it needs to be a 15-inch is beyond me. But let me tell you what we're looking at here, guys. Okay, let me zip back up here to structure 1, our very first one that we put in. What we're looking at here is not the do-all and end-all. Okay, that's not what this is. This is a place to get you started. Okay, this is a thought. This is a computer's interpretation. We all know our brains are going to be much better than this, but it does give you a starting point, and that's what's key. That's what's critical here. And so, with this tool, we have a tool that gets us from point A to point B. Here's our start. Now you come in here and do your stuff. You come in here and set. You could set this to none, and now you've got total control over every invert, pipe slopes, the whole 9 yards. If you want drops, drops. You know, it's perfectly fine. Because if we were to change the, let's just say this guy right here. Let's see, upstream to downstream. Let's just change this to, let's say 56 and click OK. All of a sudden now the HGL's changing. You can see what's happening on the fly. All that kind of good stuff is happening right here just by making small changes, putting drops in, changing pipe slopes, whatever the case may be. You know, you've got that power. Now other tools, Network Head say, yeah, let's go ahead and save it. So other tools that we got in here too that we could do also is if we were to draw our sewer network, let's just say we draw a profile. Okay, our downstream structure, I'm going to pick, because I don't know exactly what the hell number that is, but I'll come down here and pick that and pick my upstream structure and pick, okay, and I'm just going to draw, I'm going to let it be just like this. I'm not even going to draw existing surfaces or none of that stuff. Say okay, I'm going to let this ride, yes, and now it wants me to draw my network. It's telling me the length, continue. What you're going to see is I'm basically just going to zip out here and draw my profile of my pipes. Okay. Now we can also change and design right here as we're doing all of this. So if I want to edit sewer structure profile view, if I select the downstream end of my pipe, I can move it up and down. If I want to type in the elevation, I can type in the elevation. So if I was to say 2580 right here, we can edit these. It updates, it draws on the fly, it does all that kind of good stuff. And if I had to draw on the HGL would have updated too. So that is really a very quick overview of pipe design and simple layers, and you know, to use this tool. That's really all you need to get started. You know, Lee, are you there?
Yes, we don't have any questions right now. If you do have a question, please get them into the box. And if you think of a question afterwards, you can email us at info at carlsonsw.com, and I will shoot those over to Mark. And as always, you can find this YouTube recording up on our YouTube page, YouTube/Carlson Software. And we have a little break in our webinar series until June. We're still planning out for the second half of the year. So stay tuned for the updated lineup. You can find that up on our web page. And we do have one question from Curtis, and he says, will it plot sumps?
So, yes. Yes, it will.
Okay. And then we have, that's a good answer, from Pat, will this display if there are parallel lines merging rather than the series example? Sorry, there's a typo in that. Does that make sense?
Parallel lines, like I'm not exactly, but you know what you can do? You can draw parallel pipes within a swath width on this program. So if you have other networks that you want to see the parallel pipes with, then yes, I draw all of my storm drainage and my sanitary all in one profile, so that when you see mine, you automatically, you know, you're checking for service clearance. In this case, you know, when we do lateral check, or when we do crossing checks, it's only at the crossing of the pipes. You still have to know how that, if you got to come out of the top of a sewer line with a service that goes at 1% underneath storm drainage, you still got to kind of modify that yourself and watch that yourself. But I'm working on it.
Okay, great. So that about wraps it up. Mark, if you have last words, go for it.
Thank you all very much for attending. And if you need me, I do a lot of civil, I do a lot of hydrology support and training. You can find me at mlong@carlsonsw.com. Thank you.
Awesome.
Thanks, Lee.
Thank you, Mark, and we'll hope to see you in the next one. Bye, everyone.